Improper integrals is the last thing in the unit that we have to talk about. And the thing that makes integrals improper, there's several things. First of all, maybe they have an infinity or a negative infinity on the integral sign. That makes them improper. Another thing that would make them improper is like if you have the integral of 1 over x, if one of the limits, if you plug them in, if you would get undefined, for example here, if I plug in 0 to that, I would get 1 over 0, and that makes that undefined. That makes that improper as well. Most of, or all of the ones that we've done up to this point have been proper because we've been able to just find the antiderivative and then plug in the numbers and subtract and get the answer. This part is a little bit different because you can't just plug in infinity and get an answer. Basically what's happening is at the end you find the limit of it as it approaches those values. So let's look at some examples. I think the hardest part here will be remembering how to find the antiderivatives of everything, and then you have to figure out how to use the infinity and negative infinity and so on signs in order to solve the problems. So here, the very first thing I'm going to do is I'm going to find the antiderivative. This is x to the negative 2, so the antiderivative would be negative 1 over x. Add 1 and divide by it. And then you want to evaluate it at 1 and infinity. Now, you're not really plugging in infinity. Technically, when you do that, you're finding the limit as x approaches infinity of negative 1 over x. And then minus, and you can plug in the 1, minus negative 1 over 1, so that would be plus 1. So I do this part first. The limit as you approach infinity of that part right there would be 0, so you get 0 plus 1, and then 1 will be the answer. All of these you'll have to evaluate, so remember you plug in that one first and then that one. When you're plugging in infinity or negative infinity, you're just finding the limit of that piece of it. Alright, so here's another one. The reason that this one is improper is because we have that infinity sign. So first thing, find the antiderivative. Remember this is x to the negative 1/2. So I'm going to add 1 and then divide by it. So divided by 1/2 is times 2. Plug in 1 to infinity. Remember that part where you're plugging in infinity, you're really finding the limit. And then minus, and you plug in the 1. So on this one you get a big number minus 2, so infinity is the answer, and we say this diverges. Now, what we mean when we say diverges and converges on problems like this, see this problem right here is really finding the area. If I graph 1 over x squared, it looks kind of like this right here. And so when I say that I'm trying to find the integral from 1 to infinity, I'm trying to find this area. And we say it diverges because the limit of the area doesn't equal anything. Now on the previous problem, it's similar, except the part that we're trying to find, it goes to the x-axis a lot more quickly. And so that we say that that area, I guess 1 would be up here somewhere. We say that that area converges to 1 because it's really, really close to 1 in the limit. But this one, it must not get to the x-axis close enough so that we can estimate what that limit would be. So we say that that limit would be infinity. Okay, well, this one is improper because of the negative infinity. So the very first thing I'm going to do is I'm going to find the antiderivative. I know that the antiderivative is e to the x. I'm going to evaluate it from negative infinity to 0. I can plug in the 0 like normal and then subtract, and I know that I'm doing a limit of that part of it. Alright, e to the 0 is 1. Now, I'm plugging in negative infinity. Well, that's kind of weird. because you get e to the negative infinity. Well, that's the same as 1 over e to the infinity. So when I'm plugging in negative infinity there, I get that. And you really should change it to this, because now I know that the derivative or the limit of that 1 over e to the infinity, that's an infinity on the bottom. So 1 over infinity, I know that's 0. So this particular problem converges to 1. Again, just thinking about the graph, e to the x kind of looks like that. And if I'm going from 0 to negative infinity, then I'm finding this area, and it must get to the x-axis really close so that I could estimate that that area would be 1. Alright, this one is improper because of the infinity and the negative infinity, so that's kind of strange. Now, this one is kind of weird because this is not one of our normal formulas. I don't know if you remember this, but that is the formula for arctangent. The derivative of arctangent is that, so that means the antiderivative here is arctangent of x. Now, because of the type of problem that it is much easier on this problem to find the integral from 0 to infinity of that and then multiply by 2. So we're going to say that this is the same as 2 times the integral from 0 to infinity of 1 over 1 plus x squared. And the reason is because if you do this algebraically, everything's going to cancel and you'll get 0, and 0 is not correct as far as the area is concerned. So when I find the antiderivative, I get arctangent. That 2 on the outside, I'm going to put it on the outside. And then I need to evaluate it from 0 to infinity. So we have 2 arctangent of x, and we're going to find the limit as you approach infinity. And then I'm going to plug in 0 minus 2 arctangent of 0. Well, arctangent of 0, that means what angle, when I take the tangent of it, do I get 0? Well, that's 0, so I know that I can already cross that out. So here, I'm trying to find the limit as you approach infinity of arctangent. Alright, I don't know if you remember what this graph looks like, but arctangent sort of looks like this. You don't necessarily have to remember it, but what I do want you to remember is that it approaches pi over 2. So I want you to remember that arctangent of x, the limit as you approach infinity, is pi over 2. So this would be 2 times pi over 2, and so you get pi for your limit of your area. Alright, here's another one, natural log of x. This is one that you probably don't remember what the antiderivative is. If at this point, if you want to start memorizing it, you can. I'm going to remind you how you do that. This is with u and the v prime, where you have to do integration by parts. The reason is because I don't know the antiderivative of ln of x unless I memorize the formula. So u is going to be ln of x, and v prime is just going to be 1. That means u prime is 1 over x because you find the derivative. V is x because you find the antiderivative. So then you do uv minus v u prime minus the integral of v u prime, which x over 1 over x gives you a 1. So then the antiderivative would be x ln of x minus x. If you want to memorize that, great. But now I'm going to plug in the 1 and the infinity. So we'll have the limit as you approach infinity of x ln of x minus 1. And then I'm going to plug in 1. So I have 1 times natural log of 1. Natural log of 1 is e to what power is 1, so that would be 0, and then minus 1, so minus negative 1. And so that gives us the limit as you approach infinity. You see minus 1 plus 1, so really of just x ln of x. And then there you get infinity, which means it diverges. Alright, so now let's say we have the integral from 0 to 1 of 1 over x squared. So all the other problems I think had infinity or negative infinity. The problem on this one is the 0. If I would plug in the 0 there, I get undefined, and so that's what makes this one not good. So you just solve it like normal. Find the antiderivative. This is x to the negative 2, so we add 1 and divide by it, negative 1 over x. We're going to evaluate it. You can go ahead and plug in the 1. And then here you want to do the limit as you approach 0 of negative 1 over x. So we have negative 1 minus, alright, let's see, we would get, plugging in a 0, these two negatives make a positive, 1 over infinity is, 1 over 0 is infinity. So if we add negative 1 to infinity, we get infinity. So that means that diverges. Okay. On this one, the 1 is the problem, because 1, if I plugged in the 1, I would get 0 on the bottom, so the 1 is the issue here. This is another one, you just need to know it. This is arc sine of x. So since 1 was the issue, then we're going to do the limit of the 1, and then plug in the 0. Alright, I know that the arc sine of 0 is 0, because that means what angle gives me 0 when I take the derivative of it, or when I take the sine of it. Now here, this would be arc sine of 1. So arc sine of 1 means what angle would give me 1 when I take the sine of it. So the sine is the y value, so right here at that angle, the sine would be 1. Well, that's at pi over 2, and so this one you were able to just plug in the number and get an answer, which was really nice. Sometimes you'll be able to do that. Alright, another one that I want you to be able to solve, I was looking to see what number this was. This is number 7, so the next one will be number 8. I wanted to remind you about a problem that looks like this. And it looks like 4 and infinity are the problem, so I'm just going to rewrite that, and let's make this a 1 so that the only problem is the infinity. Alright, this is partial fractions, so I just wanted to remind you what it looks like. You want to factor it, and you say, okay, that it's a plus b over each of them, and that equals 1 over them. So then I multiply, get common denominator, so we'd have ax plus 4a plus bx minus 4b equals 1. So all the x's, there's no x's over here, so a plus b equals 0. All the b's go together, 4a minus 4b equals 1. So here I get that a is negative b. So plug in the negative b. So now that I have a, I can come back over here, plug in a negative 1/8, so I get 1/8 for a. And so the antiderivative here would be 1/8 natural log of x minus 4 minus 1/8 natural log of x plus 4. Now, I wrote plus c, but really we're not going to do a plus c because we need to evaluate it at 1 and at infinity. So the infinity part is the limit. So we have the limit as you approach infinity of each of those. Now, there's a rule about natural logs, and it's going to make your problems easier to solve if you'll combine them. So really, I take out the 1/8, and then I divide the x minus 4 and the x plus 4, since I'm subtracting them. And then minus, and now plug in 1 into everything. And you can plug it in like right here where I rewrote it, or you can plug it in like I rewrote it up there. Keep in mind that those are absolute values. So I'm just going to plug it in right here. 1 minus 4 is -3 over 1 plus 4 is 5. It's the absolute value, so that would be natural log of 3/5. That'll be in parentheses. Now, to finish, I know that the limit as you approach infinity of x minus 4 over x plus 4 is 1. So I can just plug that in. Alright, e to what power is 1? That's 0. So that's 0. And then so I get -1/8 ln of 3/5. That seems kind of strange because these are areas, and it looks like you get a negative, but if you put that in the calculator, you actually get a positive number. So same process until you get here, and all I did is sorry about the bells, it seems I always am doing this during the bell time. Only other thing I did is I took out the 1/8 and I divided, since it was an ln minus another ln. Now, I just want to remind you about a couple other problems, like how you would find the antiderivative, which is not really the issue here, but sometimes I think people still have some trouble. So let's say you had integral of natural log of x over x and the integral of x ln of x. Both of these problems you're going to do u substitution. You would let u be ln of x and du would be 1 over x. So, because both of those have a 1 over x, so this would be the integral of u, this would be the integral of 1 over u, and then you could go from there. Let's say you had the integral of x ln of x. On that one, you have to use integration by parts. U would be the ln of x, because I know that u prime is 1 over x. V would be x, which means v prime, you take the antiderivative, would be that. And then you do uv minus integral vu prime. And I wrote those backwards. It's still the right thing, I just put the v prime in the wrong place. And I'm not going to work all these out, I just kind of want to remind you how you would do them. If you had the integral of x to the third to the negative x, this one is tabular, because I know that x to the third goes down to 0. So you start off with x to the third, and you keep finding the derivatives until you get down to 0. And then you do e to the negative x here, and you find antiderivatives. And then once you do that, then remember you do the crossways thing, and remember you do plus, minus, plus, minus, plus, minus. Alright, 2 more. They're very, very similar, but they always seem to mess everybody up. On both of these problems, u substitution is how you should solve it. On this one, u is going to be 1 over x, and du is negative x to the negative 2, and that's nice because all you're missing is a negative. Over here, the u is again going to be the power. Du would be 1/2 x to the negative 1/2. That is x to the negative 1/2 since it's on the bottom. So all I'm missing is a half, which means there would be a 2 outside. Alright, so here's your try problems. And I hope I reminded you enough just a minute ago about how to find the antiderivative that these won't be too hard. On this one, the problem is 0. On this one, the problem is infinity. And on the second one, the problem is the 1, because ln of 1 is 0, and you have a 0 on the bottom.